In this problem, we will be using right triangles in space. So here we go. A radar tower 27 meters tall is supported by guy wires anchored on the circle shown. How long must the wires be to make the tower rise at a right angle to the ground? You'll notice the tower rising up, and then we have the radius of the circle. So we're going to draw an auxiliary line from the base of the tower out here to the base of the guy wire. And remember that a circle is the locus of points which are equidistant from a central point. So if this is 36, that is 36 also. So that is 36. And next we will draw a plane representation of this triangle. Remember, this is a right triangle. So that is 27 and that is 36. So something you'll need to remember for geometry and beyond is Pythagorean triples. You don't have to remember them, but it's going to make your life a lot easier if you do. We have 3, 4, and 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, and 9, 40, 41. You will really need to remember 3, 4, 5, and 5, 12, 13 for the ACTs coming up for later classes. For geometry, you should know all 5. Now what we're doing here is a multiple. So now multiples of these are also right triangles. If we have 3, 4, 5 times 2 is 6, 8, and 10. You could also multiply by 3, 9, 12, 15. You could multiply by 4 and get 12, 16, 20. For these, we are multiplying by 9. 3 times 9 is 27. 4 times 9 is 36. And then 5 times 9 would be 45. So we will put that over here in green just to make the point. So the length of this guy wire is 45. For that matter, the length of this guy wire is 45. And the length of that guy wire there is also 45. Now for the second question, is this true of any guy wire that extends from the top of the tower to any point on the circle? And the answer is yes. We could go there, we could go there, we could go there. Remember again, a circle is the locus of points equidistant from a central point. So all of these distances here would be 36, 36, 36, on and on and on. The tower is a constant 27, so any of these guy wires would be 45.